Hello juniors, today we're going to see electronic assignment 16, which is about trigonometric functions. We're going to see this last type of function for this year. And let's see. The objectives for today's class are: number one, graph circular function. Circular function is a synonym for trigonometric function. It's called either trigonometric or circular function. Number two, find the period of circular or trigonometric functions. Number three, find the amplitude, and there's a p missing here, amplitude of circular functions. Then number four, find the vertical and horizontal translations of circular functions. And number five, find vertical and horizontal stretches of circular functions. So basically we're going to study this type of function, the trigonometric or circular function, and how the different types of transformations apply to this function. So the two basic trigonometric or circular functions are the sine and cosine functions. So to start with, we're going to graph using our calculator these two functions, sine of x, and the second function would be cosine of x, just to see how they look like. We've got the calculator now. We would go to menu graph, right? And we're going to graph both functions. We erase this, and we're going to write sine of x first of all, and then we're going to see sine of x first, and then we're going to see cosine of x. Before we actually graph, we need to see that our calculator is set up to angle. It should say radians. If it says degrees, you should change to radians, okay? So we draw this, and we still cannot see because our scale is wrong. We're going to go from 0 to 2 pi to make our graph, 0 to 2 pi. Scale would be, we're going to go from 1 to 1, and we're going to go from -2 to 2, scale 1, just to see how this function looks like. So this is the sine function. You see that it starts at 0, and then it covers a full period, and it ends up in the same place, right? Now, if we graph the second function, which is cosine of x, you will see how this function looks like. You see that it has the same shape, but it's kind of displaced, right? So that's exactly what you see in this graph over here, right? So these are the two functions that we're going to be analyzing. It says you can see many similarities between sine and cosine curves in this diagram. So the blue one is the sine function, and the green one, the dotted one, is the cosine function. So what are the similarities that we see here? First, the curves are the same shape, right? They both have the wave shape. Then it says the curves are at the same height, right? The maximum height for both is 1, and the minimum height for both is -1. Both functions have a maximum value of 1 and a minimum value of -1. Another similarity, translating the cosine curve, the dotted line, pi over 2, to the right, if I move this pi over 2 units, it will match perfectly with the sine function, right? So it says to the right makes it identical to the sine curve. That's another characteristic. Then it says both functions complete one wavelength in 2 pi radians. So for example, cosine starts here, and then it goes up to the same point after 2 pi, right? And same thing happens for sine. It starts here, and it ends up in the same spot here after exactly 2 pi, okay? So that's what we know as the period. We're going to see that in a while. Then it says the functions are periodic, meaning that they repeat the same cycle of values over time. So if we expand this function, the blue one, it will continue repeating its pattern indefinitely, right? And the same thing for cosine. It will repeat its pattern indefinitely until infinity, okay? Then it says, if we compare the sine and cosine functions, we see many similarities. This is kind of a more expanded summary of what we just read here. It says, the curves are the same size and shape, only their horizontal positions on the axis differ. The sine curve passes through origin, 0, 0. You see, here we have sine, here we have cosine. So the sine function always starts at 0, 0, while the cosine curve passes through the points 0 and 1. So the cosine function starts at 1, while the sine function starts at 0. That's one very important difference you should know. Then it says, the functions are periodic, which means that they repeat the same cycle of values over and over. The period, or the length of one cycle, is 360 degrees or 2 pi radians. This means that if you look at 2 points whose x-coordinates are 360 or 2 pi apart, the y-coordinates of those 2 points would be the same. So for example, this point repeats exactly here. 2 pi, this is 2 pi or 360 degrees later, right? And same thing for sine. It starts here and then it repeats its same value right here after exactly 2 pi or 360 degrees, okay? That's what we know as period. Finally, it says both functions have maximum value 1 and a minimum value of -1. Each of these functions has an amplitude of 1. Amplitude of 1. The amplitude is the difference between the horizontal axis of the wave, y equals 0 in this case, to a maximum or minimum value, y equals 1 or y equals -1 in this case. We can also say that the amplitude is 1/2 the vertical distance from a maximum to a minimum. We're going to see that later on in examples, okay? But these are the 3 most important things you should remember from the periodic or trigonometric or circular functions. You should know the origin, the period, and the amplitude of this in order to be able to solve problems. Okay, then it says, characteristics of sine and cosine functions. This graph shows the function y equals sine of x, so this is a sine function. The amplitude is half of the difference of the maximum and minimum values. That is, the y value at point A minus y value at point B divided by 2. So this is exactly the amplitude, which, as the text here says, can be found by also doing this point minus this point. So the y-coordinate of this point minus the y-coordinate of this point, and then we divide by 2 the difference in order to obtain this distance over here, which is exactly the amplitude, okay? So that's another way to determine the amplitude in case you cannot measure this distance directly. This distance or also this distance is the amplitude. Okay, let's do this investigation. It says, use technology to help you sketch the graph of each function for 0 to 2 pi. So we want to graph these 3 functions, y equals sine of x, y equals 2 sine of x, and y equals 3 sine of x. So for that, to graph these 3 functions, I'm gonna use Desmos to be able to watch this more clearly, okay? So I'm gonna go to Desmos, and we're gonna graph. The first function was sine of x, so this is sine of x. Then we have the second function, which said sine of 2x, sine of 2x. And finally, the third function, sorry, not sine of 2x, 2 sine of x, it said. Let me see. Yes, 2 sine of x and 3 sine of x. So we're going to go back. We should write here 2 sine of x. And finally, 3 sine of x. So what do you notice here? Let's see. 3 sine of x. What do you notice? If we zoom in here, let me see if we can see the 3. There we can see the 3. These are all sine functions, right? Let me see right here. These are all sine functions, and you see that the red one has an amplitude, or its maximum value reaches 1, right? While the blue function, its maximum value is 2, and the third function, its maximum value is 3, right? So that's a very important thing you should remember. If we go back to the assignment, and it says, find the amplitude of each graph. If we find the amplitude of each of these graphs, we would see that for the graph A, sine of x, the amplitude, we're actually doing part D, let me see how, for D, the amplitude of sine of x, let me write function here, and amplitude. For the function sine of x, the amplitude is 1, right? If we go back, the maximum value it reaches is this point over here, 1, right? The maximum value of the blue function is this one, which is 2, and the maximum value for the green function is this one, which is 3, okay? So for a 2 sine of x, the amplitude would be 2, and for 3 sine of x, the amplitude is 3, okay? So then it says, how could you have found the amplitude by looking at the equation? You see that the amplitude is given by the coefficient which is in front of the trigonometric function. So that's exactly what we can visualize here. Amplitude is given by the coefficient in front of the function. There you go. And then it says, could the amplitude be negative? And the answer is no. Remember that the amplitude is a distance, right? And a distance can never be negative, right? We could have, however, for example, minus 2 sine of x there, but our amplitude would still be 2. What this minus is doing, it is causing a reflection of the function, right? So that's the consequence of adding a negative sign in front, but the amplitude will always be a positive number. That's something very important for you to remember. Then for the second part of the investigation, it says, use technology to help you sketch the graph of each function. So now we're going to graph this function, y equals sine of x, sine of 2x, sine of 3x, and sine of 0.5 sine of x. So we're going to see the differences here to see what happens. Now we're adding the numbers inside the x value, right? So we go to Desmos, we're going to erase this 2, we're going to keep the red one. So now we're going to plot sine of 2x, then sine of 3x, and finally the second one, the last one said 0.5 sine of x. I think that's a mistake from the book, but let's do it, sine of x. So you see that now what is changing is the period of the graph. Let me erase this one for a second. If you take a look at the purple one and compare it to the red one, you would see that it has the waves repeat faster, right? Or at a shorter interval than the red one. And if I increase the number inside, if you compare, for example, these two, you would see that again this function repeats more times than the original function, right? So what the number inside of the x is causing is a change in the period of the function, okay? If we plot this last case, you would see that this is the first case we were studying in which we're changing the amplitude, but not the period of the function. Both of these functions repeat at exactly 2 pi, which is 6.28, right? But they both have the same period, right? The only thing that changes is the amplitude in this case. Okay, so let's go back. And we're going to say that it says the period of a trigonometric function is the length of one full cycle along the x-axis. Example given, the angle measured after which the graph begins to repeat. Okay, so the only thing that we will say here is that when we change the numbers inside the x, we're changing the period. Okay, so the period of the function changes. That's what we can observe in this part, okay? So in this case, we changed the amplitude, and in this case, we're changing the period. Okay, so to generalize what we just said, it says, for the curve y equals a times sine of bx, or a times cosine of bx, the absolute value of a, that is the number that is in front of the circular function, is the amplitude, while the period is given by 2 pi over b. This is like a formula that you need to remember because it's not in the formula booklet. To find the period of a function, you need to perform this operation, 2 pi over b. Let's see this. I forgot to show you this in the investigation here. For example, this function over here, sine of 2x. If I plot that function, sine of 2x, let's analyze only this purple one. What would be the period of this function? You see that it starts at 0, 0, and then it ends its first period right here, okay? You see that the value of x is initially 0, and then the value of x when it ends the period is pi. That means that the period of this function is pi, right? So the period, let me write that here, function and period. if we're analyzing the period, we would have that if the function is sine of x, the original one, we know that its period is 2 pi, right? If the function is sine of 2x, from this graph over here, we see that the period is exactly pi, right? So the period is pi. Then what if the function is sine of 3x? If the function is sine of 3x, let me draw this one over here. It starts here at 0, 0, and it ends its first period right here. So it's 2 pi over 3. That's the period. Let me show you again. There you go, 2 pi over 3. So if we go back, the period now is 2 pi divided by 3. And if the function is 0.5 times sine of x, we saw that the period does not change, right? Let me draw that again. If we draw this function, you see that it starts at 0, 0, and it ends right here, which is 2 pi. So the period remains the same as the original one, and it's again 2 pi. So if we apply this formula, you would see how the period works. The period of any trigonometric function is found by doing 2 pi over b, where b is the number we have right besides the x, right? So period. So if we apply the formula, for example, in number 3, we would say that the period is found by doing 2 pi divided by the value of b, which in this case is 3, right? So 2 pi over 3. And we get exactly the same value we have here. Or if we apply the formula for this function over here, where b is equal to 2, this would be 2 pi divided by 2. And 2 pi divided by 2, if we simplify, is just pi, which is exactly the period we got here, okay? So you see that this formula actually works, and as I told you, this is a formula that is not available in the formula booklet. You should remember this formula. Period equals 2 pi over b. Okay, then it says y equals negative sine of x or y equals negative cosine of x is a reflection in the x-axis. If you remember from transformations, which is one of the first things we saw this year, adding a negative sign in front of the function causes a reflection on the x-axis, while adding a negative sign inside the parentheses or inside the x causes a reflection in the y-axis. So that's something that you should just remember. Okay, so let's see 2 examples to finish this first part of the video to see how these concepts apply. It says, sketch the graph y equals 3 cosine of 2x for this interval from 0 to 2 pi. Okay, so first thing, from this function, we can identify 2 things. We can identify, or three things actually. The first one is that we're talking about a cosine function. Since we're talking about a cosine function, so cosine function, we know that it should start at point 0, 1. Starts at point 0, 1, or actually 0, 3 would be in this case, and let me explain you why. Actually, before doing this, I'm going to write 2 things. First one, the value of the amplitude, and number 2, the value of the period, okay? So for this function, the amplitude, we already know that the amplitude is given by the number in front, so the amplitude is 3, while the period of this function, we need to calculate it by applying this formula, right? The period is 2 pi divided by the value of b, which in this case is 2, right? So 2 pi over 2, so this is equal to pi. So we have 2 of the most important information we need, the amplitude and the period. If the amplitude is 3 and we have a cosine function, the cosine function always starts at its maximum value. Cosine function starts at its maximum value. So if the amplitude is 3, that means that it should start at point 0, 3. It begins at its maximum value. Remember, we saw that here, right? Cosine begins at its maximum value. That's why we wrote the point 0, 3 in this case because 3 is the amplitude of the function. So if we want to graph this from 0 to 2 pi, then let me do the coordinates here. We're going to have the y-axis. That should go up to 3 maximum. So 3, 2, 1, 0, negative 1, negative 2, and negative 3 would be our minimum value. So this is y. And here we would have x. This is only a sketch. We don't need to be very precise. So we can say that, for example, this point is 0. And let's say that 1, 2, 3, 4, 5. Right here we have pi. And 1, 2, 3, 4, 5. Right here we have 2 pi. Okay? So we know that the cosine function starts at its maximum value, 0, 3. So we have a given point here. And then we also know that the period is pi. That means that the function must be at its maximum value again after pi, right? After exactly pi. So we move up to pi and we have this point over here. And then we can draw the function. We know that in between two maximum values, remember this is a maximum, this is another maximum, and exactly in between two maximum values we should have a minimum value, which would be negative 3 in this case. And it's in the middle. Yes, it's in the middle. So we can repeat this right here. At 2 pi would have a maximum again. And then in between these two, we're going to have a minimum. So with these points, we can already do our sketch by using our hands only. We do not use ruler for this. So we use our hands and we join the points. And then we have a sketch of the cosine function. Okay, so that's how we can quickly sketch a trigonometric function by knowing this information over here. Now, let's see this example to finish this. I'm going to do it here. It says, write down the period and amplitude and find the equation of this function. So we want to identify the period and amplitude. The easiest is always the amplitude, right? We can determine the amplitude just by observation. The amplitude is this distance over here. So we know that this is 0, and this point over here is approximately 0.5, I would say, right? 0.5. So the amplitude of this function must be equal to 0.5. Let's see if I can, yeah, kind of like there. So the amplitude is 0.5. And now we need to determine the period. To determine the period, it's kind of difficult in this case. I see that, for example, this function starts at 0, 0, and then it completes one cycle here, then it completes a second cycle right here, and then it completes a third cycle right here. So for the period, we could say that it does, covers a total distance of 2 pi, this is 2 pi, in 3 cycles. So the period will be 2 pi over 3, okay? One period is 2 pi over 3. But in 3 periods, or in 3 cycles, we cover a total distance of 2 pi, okay? That's why the period is 2 pi over 3. I hope that was clear for you. And finally, we need to determine the equation, right? I see that this function is beginning at point 0, 0. So which of the two began at 0, 0, sine or cosine? If you remember, the sine function is the one that starts at point 0, 0, right? So we should know that this function, let's call this f of x, must be a sine function, right? And we need to write the amplitude in front. So this is, I'm going to write more space here, 0.5 times sine of, we only have the value of the period here, but we need to find the value of b. Remember that the period is always equal to 2 pi over b, right? Over b. So here we have the value of b, which is 3. So this is times 0.5 times sine of 3x. So this is the function that is being graphed right here to the right, okay? So this is how we determine the function if we're given the graph of the function, okay? So I hope that was clear for you seniors. Next class, we're going to see the other two remaining transformations, and then we're going to be applying this to different types of exercises. So I hope this was clear. If not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention, and see you.